and thank you for coming in and taking time out of your busy schedule on a beautiful Saturday, nonetheless. And so we're going to discuss Drupal 8 caching. So an interesting thing about Drupal 8 caching is that the majority of things that are happening in Drupal 8 caching are not in Drupal 8, but are instead in the environment all around. So I'm Peter Sawczynec, and I work at Pantheon as a senior customer success engineer. And so every day I'm essentially a type of tech support, but it's a tech support that is designed to make your website successful. So if you have roadblocks or stumbling blocks, that's not good for us. We don't really want you to have that experience. So we're there to help you with almost any kind of issue. And we give you some information to help you move ahead. And so that's what I do every day. And it's been my experience in the last several jobs I've had and here at Pantheon, especially ultimately with enterprise websites, a substantial part of your day is going to be to talk about caching and work on caching issues. Because there does come a point where if you're not using serious caching now, you are ultimately going to need it. When you get to that point where you have 1,000 users a minute or 10,000 users a minute or whatever it is, only caching is going to save you and make it possible for your website to stay up. So that's the point here, is that so caching isn't really about the technological achievement. It is actually about your site being capable, smart, and fast in this day and age where, you know, like everybody expects everything to be dynamic. I should see all my favorite articles. I should see the weather. I should see everything that's going on Facebook. So, well, you're aware that that's technologically difficult to achieve, but you do finally weave it all together. And then so you want the website to be fast subsequently, though, too. So that's where the caching comes in. And originally, a lot of the thought about caching was that it was anonymous, monolithic, and full page. And that's how it used to be. But what actually caching turned out to be was sort of multi-level. There is totally anonymous, full-page static caching, but a lot of it is actually partially dynamic. And you pull in additional content using Ajax, for example, where you load a full page, but then the weather comes in, you know, as a separate block, and the latest stories come in as a separate block. And you see that experience when you're surfing websites, when you see the spinners. And if you go to a website like Mashable, for example, their website is infinitely Ajaxing in content for you. Every time you move the website, you know, and it knows what is the next blog post to pull in, and that just keeps coming in. And large websites like the New York Times, who have 1,000 comments on a single article, they cannot possibly load that for like 1 million users all, you know, in real time. So today they've put comments aren't even on the article anymore. You got to ask for them separately. And there's a lot of websites that do that today. The article shows up, but they can't load all the comments because that's just not possible. So you have to hit a button and say, I want to see the comments and I want to participate, and they come in secondarily in Ajax. And I'm bringing up Ajax because people often get stuck. They're like, well, how do I get dynamic content, custom content on a fully cached, you know, Varnish page? And that's one of the easy methods, is you use Ajax to pull in blocks. And if you're not familiar with Ajax, in the world of Drupal, you can Ajax blocks in by turning on a module called Blocks Ajax, or you can add some script and do it on your own. And views in Drupal is Ajaxable by simply turning on a check mark on every view. You can turn on a check mark and say, make me Ajaxed. And then on top of that, all the pagination can be Ajaxed, so that if you have a view with, you know, 10 interesting news articles and the user says, show me the next 10, if you've turned on Ajaxing pagination in views, instead of the whole page reloading, just that little block reloads. Okay, so that's where we are here, where we're saying that caching in Drupal 8 can be several different things. It can be an entire web page, it can be a portion of the web page like a block, or it can only refer to the data that's being used to make this web page. And all of these items can be cached. And so I'm recommending to you that if you want to get into an aggressive caching plan, that you do have some kind of a strategy. And it might seem at first impossible if you've got news-oriented web pages, user-oriented web pages, admin in the background, anonymous pages, but it is actually not that difficult, and there are actually only several different kinds of pages that you need to consider. And that is, fully cached, partially cached, and never cached. And once you have that structure in the background, you can start making decisions about how you're going to cache things. So now we're going to just step back for a moment. And so this is actually called the Edge Architecture Specification from W3C. And what this says is that your web server is called the origin. And it actually sends information down the pipe to all of the proxies between you and the ultimate user at the browser. So all of those people in the middle are called a content delivery network. And now we have a very nice graphic coming up. So, but essentially, in your web page, there's headers, and headers have information like cookies, security, and caching information, along with many other things. And it's in headers where your caching instructions are going on. So the origin, your web server, is allowed to send controls downstream in surrogate control headers, because it wants to tell all the surrogates, all the proxies in the middle, what to do with your content. And the surrogates themselves advertise their capabilities up to the origin. And so this like hidden transfer of information is going on in your headers, in your HTTP headers. So this is a very good chart, and really this is like the heart and soul of this entire dialogue here. So and as you can see in this blue box, this is Drupal's participation in this full spectrum of caching. So your MySQL server caches queries within itself, which it's not telling you about. But MySQL's caching is so excellent, you really never have to deal with it. But essentially, once you make a query, MySQL will cache those results. And if that query happens 100 or 1,000 times today, MySQL will not run the whole thing over. Unless some tables change and it knows information changed, it will run the query again. But essentially, it has it cached, and it returns you the cached data for the same queries over and over again. So there is a form of PHP caching called APC, and what happens is, PHP writes all the bytecode that actually processes your page. And then it does the same thing. It takes all of its built code and it caches it. So every time a request comes to rebuild that page, unless there's something that's changed in it, it doesn't have to rebuild it again inside of its own internals. So you have caching going on there. Then there's caching called object caching, which is handled by Redis and memcached. And that's essentially, once you turn these modules on and you configure them, when your code goes to say, and it wants to make a MySQL query, Redis is already waiting in the middle and going, you just ran that query, and there's been no change in the information. I've cached it. We're not even going to go to MySQL, and Redis is going to return that information for you, or memcached. So, so the reason why that exists is Redis is faster than MySQL. Because the information does not have to be read from tables and recompiled, Redis is like Varnish, just like a lightning response. It's either there or it isn't. And so it's not doing any calculations, so it becomes faster. So you have that level of caching. Now this has all happened before we get into Drupal. So but now we finally make it to Drupal. This has percolated up your cached queries, your cached query objects, your PHP, your bytecode that's been cached. Now we make it up to Drupal. So Drupal has the performance page settings configuration, and then nowadays in Drupal 8 you have a couple of dynamic cache modules and you have BigPipe. So we're going to look at these a little further in the show, but I did want to talk about these two dynamic page cache modules. So Drupal 8 comes prepared for you to give you caching on the level of what Varnish caching accomplishes for you, but just in case you don't have the means to even have a Varnish cache server in front of your website. Now that's pretty rare nowadays, but it could happen. So between a couple of dynamic cache modules and BigPipe, if you turn it on, Drupal is basically saying for you, I can turn your Drupal site, your Drupal 8 website, and make it act like as if it's being Varnish cached. But so here's something I want to point out. Varnish Cache is actually taking place over here in front of Drupal. So it's supposed to actually be handling all the caching. But if you have these two internal modules turned on, Drupal is going to, like when a request comes in to the web server where Drupal is basically, controlling everything. Let's say it's made it past Varnish, and you come over here. So Drupal has the ability internally to cache inside the database and not on the Varnish server the content of your website. And Drupal will go, oh, this is an anonymous page with a whole bunch of blocks and a view, and it cached it into a table inside Drupal so that when that page gets requested again, it doesn't have to build the whole page. So Drupal will cache fractions of your page or your whole page internally if it can do it. So a problem can come up in that people give instructions to Varnish to invalidate the cache, to say this page is old, I would like it redone. But the request then will flow through to Drupal, and Drupal will go, no, I've got that cached internally and I don't have to do it over, and will return the cached content again. And so a user who's managing this can look at it and go, my Varnish cache is not getting cleared, but what's really happening is if you have these other caches turned on, Drupal keeps returning the cached content on your behalf. So typically, you would not be keeping these turned on if you have a full service Varnish server in front of you doing the caching. And I'm just bringing that up because that's come up with several people doing Drupal 8 websites, and they've had multiple layers of caching turned on, and unless you become extremely adept and you're following all your caching every day, you're going to eventually have stale content coming through, and you're not going to know why. So I'm just bringing that up because this way you can be aware of it. So now once you make it past Drupal, standing in front of Drupal is your Varnish server. And so on these servers, you can have what are called edge-side includes and server-side includes. So this graphic is a tiny bit off. A server-side include is when at the web server you put special tokens in your HTML, and then as the page is being built, you can have those blocks going even to other web servers and going to get content to put into your page. And the edge side includes, that's happening on the Varnish server, where as the cached page is being returned by Varnish to the requesting user, the edge side includes can fire off and pull in dynamic content into the page so that even a completely cached Varnish page can be pulling in dynamic information from other locations using edge side includes. And the web server can be pulling in dynamic information from other locations also on a fully cached page using server side includes. And then, as I explained earlier, all the way down at the client in the browser, you can have Node.js or Ajax firing off, which is going back again and getting dynamic information. So if you were actually using all of these techniques, edge side includes, server side includes, and Ajax, you can see that you have tremendous potential to keep a fully cached page that is being served to the average anonymous user in a fraction of a second, actually still pulling in all kinds of dynamic content from different places as you need. So I bring this up because you don't have to feel locked in, oh, if I get into a major, serious, full-page caching program, I'm not going to be able to show dynamic information to every user that's extremely current. So, because you might, for example, go, okay, in general, we're going to say expire every page after 15 minutes, and you can do that in Drupal's performance settings. You can say every 15 minutes, invalidate Varnish, and make it come and get a new page and then serve that up. So you don't have to do that. You could invalidate your pages once a day if you are using all these other techniques to bring dynamic content in. So now we've made it to Varnish standing in front of Drupal, which is standing in front of all the back end. So on the way between your website's web server, the origin, and the Varnish caching server that stands in front of it, to make it to the user's browser, there still are a couple of other potential caching points in between. And I don't know if you've had this experience, but in particular, users who might be in a university or in a huge legal office or in a government agency, the government, those large-scale network builders, the hardware people are actually like running the wires and setting up the Wi-Fi and everything. They will put their own caching server over here in front of you and in front of them to give these users better performance. And they usually don't tell anybody that that's going on. So you go over here and you build your new page and you invalidate your Varnish cache, and these people are over here and going, we don't see any of that. I don't know, it's been hours, it's been a day, and yet that update hasn't made it through to us. And then they end up finding out, oh yes, our network people actually cache our stuff before it gets to us. And then you have to figure out with them, they have to figure out a better plan where they invalidate and uncache things a little more often than they do. Now you may actually even have caching going on in between at your Comcast, every network provider that's in the middle here that your page travels through could be caching your things. So that's just worth bringing up. It doesn't happen often, but it's an edge case like that that can act as a mystery for hours or days before a final source issue is found. So another form of caching that's going on is CDNs, and that's Akamai or Fastly or Cloudflare. And so what's going on with them is they want to take your assets. This could be documents that are downloaded from pages. This could be all of the images in your website, and it could be all of your JavaScript and CSS files. Basically everything that is not dynamic content from the database and following this path. So you pay a service like Akamai to take all of your assets, all your images, all your MPEGs and everything else, and they keep them over here for you. And they put them on a master CDN, and then this master CDN actually caches all your information here in its master CDN. And then as a master CDN, it distributes your assets to multiple points of presence, they're called, all around the world. So now you've got another layer of caching here that is not in your control if you're not controlling it. So again, you could have users over here going, I don't know, we updated the image of the president, but the president's image doesn't update here in the browser. And that's because you actually will probably have an interface over here where you can actually go into your CDN and say, invalidate that picture of the president and make it go get refreshed. And then sometimes also there just are incidences where the point of presence in Spain gets updated minutes later, sometimes even days through technical issues. And since they're pulling from Spain, they don't get the update by accident. Now, currently, services like Akamai and Fastly will tell you, if you invalidate something here or if you put something in new, it will be on the master CDN within 5 seconds, and it will be distributed to every point of presence around the world within 2 seconds. They'll give you like a service level agreement like that. And so if you're going to use a CDN, you want that kind of assurance that when my assets are distributed, it's happening like really, really fast. And you will actually get that nowadays. So this is other type of caching. So this is all your web caching. Now you have your assets caching going on. And then like I told you, once you're in the browser, you can be firing off Ajax or Node.js that's going back to the server to get more content and fill in blocks, or it could even be going to other websites and making API calls. So that's essentially like the whole spectrum of what's going on in caching, and it's a worthwhile picture to have, because sooner or later it will all keep coming up. So now this is the same graphical flow, let's say, but just done without the cute graphics. So PHP functions can cache, PHP itself can cache, MySQL can cache, it can have cached data objects. Drupal 8 can be caching things itself inside the database. Then you have your Varnish caching that's going on. There could be other proxies in the middle, and then there's the browser itself. So this is another item that comes up eventually too. The browser itself is caching both your content and your assets. And if it isn't instructed to invalidate something and go get it again, the browser itself can be guilty of holding on to information and keeping it stale and having users around the world and in multiple locations get back to you and say, no, we're not seeing that content getting updated, or all that new styling that you did isn't updating in my browser. And that'll happen because the browser is like, no one's telling me to go get that JavaScript again. No one is telling me to get the new CSS. And it keeps it in its own local memory and keeps reusing it. So you can actually tell your browser to clear out the cache and go get everything fresh with what's called a hard refresh. And I don't know, it's either Control R or Command R, depending on your operating system. So if you have a user that's telling you, I don't see those style updates, make sure you tell them to hard refresh. And typically, 90% of the time, their thing gets refreshed and they get the content and they see the new styles. If they still don't, then somewhere along the way here, you have a different issue, or you actually didn't make your update correctly. There's that possibility at the end that you thought you pushed your changes live and they actually didn't go there. So, and then underlying in all of this is what I was touching on at the beginning. From the origin all the way down, it's communicating via HTTP headers, and then all of the surrogates on the way back are communicating also in HTTP headers. And basically, you get from code to the browser. So I bring this up because this is actually important, and this is a spot where I found myself, and you may find yourself if you haven't already. All of your PHP functions in PHP and within Drupal can do caching themselves, saving you some time. So, like for example, I worked on a large enterprise website where pages were loading very slow. Everything had been made thoroughbred, all the data calls, everything was fantastic, yet the pages were slow. So what it turned out to be is we had blocking Ajax calls to Facebook and Twitter going on. So in other words, it wasn't until we got all the way to the browser, where during the browser build of the DOM locally in their browsers was getting hampered because we were making non-asynchronous calls to Twitter and Facebook to get information. So this was slowing their page builds. So then you learn that you need to make your Facebook and your Twitter calls asynchronously, which means they use Ajax. So Facebook and Twitter on your behalf, if you say, hey, load me asynchronously, will let your whole page load, and then later they will fire off their scripts and come pull in the Facebook and the Twitter. So now that's an improvement in time. But as it turns out, that can be very slow, and then users are like, I don't see the Facebook fast enough, or I don't see the Twitter updates quick enough. So as it turns out, you just can't beat that system. So instead of calling Twitter on every single page load to get the latest Twitter feed, you actually only do it once every minute or once every 10 minutes. And then in between, you actually cache the response that came from, say, 2 p.m., and you keep showing that to your users until 2:02 p.m. And this is another level of caching and caching invalidation, where you make your website look fast by just actually slowing it down a little. And most users don't know that, don't experience this, like, oh, there was a 1 minute lag between when someone tweeted something and I finally saw it.
They just blame Twitter.
No one even notices. No one even notices that happens. Like, you're not aware that this was tweeted, 45 seconds ago. You're not actually following it that closely, So And all right, so that's the Twitter, Facebook thing. But internally, every time you write a function that, say, for example, has to go into the calendar tables and find every calendar, food event entry for the last year and pull it out of MySQL and then feed it back into your page load, you're slowing your page down. So you can put caching inside every function where basically your function fires off. The first thing it says is, let me go look in the cache to see if this request has already been cached by my function. And if it has been, it uses that without going out and making a MySQL call. And then if it hasn't, it goes and it makes the call, but it brings it back, and at the end of your function, you have a thing that says, cache this query, cache what just happened. And because you have this sort of like little loop going on, you never make a query that you don't have to, and you never serve stale data, because when you have to go get it fresh, you'll go get it fresh. So there's a couple of really good articles online, and everything in this presentation that has underlines in it and looks like links and it will link you to some good documentation or examples. So that's I bring that up because that's worth doing if you're not doing that. If you're not caching some of your PHP or Drupal function results, you should. So, and then there's the alternative PHP cache, which we discussed, object caching, Redis, and memcached. So whether it's Drupal 7 or Drupal 8, there's like a 3-layer process going on if you want to use Redis or memcached. So first off, you have to have the actual Redis server or the actual memcached server, which is the actual like Linux tool or thing that's running. Then you have to have a PHP library that knows how to speak to the service. And then inside Drupal, you have to have a module that knows how to speak to the library that's actually speaking to the service. So you need all 3 of these to have Redis or memcached on your website. And so this explains the slight differences and what's going on, and it tells you like what version of PHP you might need to load this library, which is speaking to Redis, et cetera, et cetera. And so if you want to get into the specifics of this, you can look these up and you can follow that. And Redis and memcached are 2 slightly different versions of object caching, and which one you need for your website and which one you think is faster and works a little better for your website, you have to actually analyze on your own. My experience has been, on the overall, most enterprise websites end up using Redis, but I'm not completely filled in on how that judgment call gets made. So we discussed MySQL query caching that's going on. And now we make it up to Drupal 8 caching, which we're going to follow up on in a moment. And so now we're going to get into headers. So like I was telling you, headers is where the caching information is getting exchanged between your origin web server and all of the surrogates and proxies, including Varnish, on the way to the browser. And these particular headers are the ones that are most involved in what's going on in caching. This one in particular, cache control, is the one that is literally telling every proxy and surrogate between the web server and the browser what they should be doing and how long something should be cached. And so we're going to discuss that. Expires is a really blunt header command to Varnish and surrogates that says, hey, this item expires on January 1st or whatever, by a literal date time. And then etag, vary, we'll get to all of these. An interesting thing to know about age. Age is not a caching command, even though it sounds like it is. Age is telling you how long has this item already been in the cache, is what age is going to tell you. So when you look in the headers and you want to check, hey, is this item in the cache? If the age is 0, no. That means it was just made. And I would like to explain a detail to you. Once you put Varnish in front of your website, everything goes through Varnish. And Varnish headers will be inside your HTTP headers all the time, even if Varnish did not cache this item because it was told not to, let's say, by the headers. So if you were to look into headers and you see Varnish tags, that does not mean this item was cached. It's just telling you it passed through Varnish. You are going to have to look at some other elements to learn whether it was actually cached, and we're going to look at that. So these are special headers that Drupal 8 makes that it can put into your HTTP headers. And these are good. So this item, now this, remember I discussed earlier where I was telling you Drupal can be caching stuff and then actually giving it to Varnish cached, so Varnish can cache it in a larger context and then serve it to the requesting user. If you see this in your headers, Drupal is telling you, yeah, I'm giving you cached content out of the database, out of my own internal cache. Drupal is telling you I had a cache hit. So that means if you don't want that to happen, you got to go in and turn those modules off like I told you. So, and this is just XGenerator. Okay, so caching contexts and tags. This is where Drupal 8 gets really good. This is where it gets really interesting. So in Drupal 8, and we're going to look at a render array, in Drupal 8, they really want you to output all of your end result material in render arrays. Render arrays actually have the ability to set caching parameters. And so let's say you make a page that has 5 blocks on it, and one of them has to be refreshed every hour, and 3 of them have to be refreshed once a day, and one of them has even it could be a year. You don't care about it at all. When you set your cache tags correctly in your render arrays, as soon as, and Drupal keeps track of all of them, as soon as it sees the one block that has the highest granularity and must be refreshed every hour, this entire page will get invalidated and created fresh every hour. Because Drupal is going to go by the most granular request for caching. So previously in the past, sometimes you would make a block and you would change it, right? And it would get stuck in a fully cached page. And you had no way to figure out, how do I communicate when this block changes? I'd like the page to just refresh itself on its own. And I don't have to go and tell Varnish to uncache the entire page because the block changed. The editor can go in and say, oh, we're changing the headline on this article. And it's very important because the first headline that got cached is not good. Now, they make that update, but then they don't see it, right? Because it all got cached on the page level by Varnish. And you have to actually send someone out there to manually uncache that page. If you're using all the cache tags, Drupal can know when this node was updated, because render arrays were used that had the correct cache tags. As soon as that event happens, Drupal is going to pass all the proper headers up the stream to Varnish to tell Varnish when to uncache your pages because something like a node was resaved or a view was redone, and it's going to be doing all that for you automatically. It is actually so brilliant that I can only tell you, if you haven't put the time in yet to learn more of Drupal 8 in this aspect alone, it's really worth your while. So, and here's Surrogate Keys. The text on here is kind of dense because it is kind of a dense topic. But so let's just go back one slide again. So surrogate keys are these things that are set by contexts and tags. And so what's happened is because all of the CDNs like Fastly and Akamai have become aware that caching is no longer such a monolithic thing and it's extremely granular, they're participating, and Drupal 8 is participating with them. And so what happens is when you set all your render arrays correctly with all their caching levels, and then Drupal manages them correctly as it's building the page, and Drupal writes the correct cache tags into the headers based on all of your proper caching information, these cache tags, when they're seen by Fastly or Akamai down here, they will actually do what these cache tags say in terms of invalidating or allowing a single page of content to stay in the cache or get knocked out of the cache. So they're listening with you, and Drupal 8 is totally set up to use this environment. So just one more time to reiterate, you have a page where even if this block changes, even if a title in this block changes, this entire page has to be invalidated. So if you do your render arrays correctly, it will set the cache tags that Drupal will read, and Drupal will put information in the headers on the way out that Varnish and Fastly and Akamai are all going to listen to, and they are going to uncache the entire page and refresh it and send it out current without you having to do anything or anyone on your team remembering to do this correctly. So there's lots of information on surrogate keys. So let's just talk about Varnish specifically. So Varnish is basically, it's another web server in front of your web server. And what Varnish does is Varnish is watching every request that comes in before it goes to your web server, and it's watching every response on the way out before it goes back to the person. And it's reading all the headers in the middle, and it's deciding whether to put this in the cache or knock it out of the cache, etc., etc. So, like I was saying, once you turn on Varnish, every request is going through Varnish. You cannot bypass it anymore. So, that's what this is saying. So, Varnish has the ability only to cache items that are called idempotent. And idempotent means a command that doesn't change things. It only asks for things. So GET requests and HEAD requests are the only two types of HTTP requests that go through Varnish that don't change things. Put requests, post requests, trace, options, and delete all change things by their very nature. So Varnish will not even look at them because it knows I'm not going to be able to cache this because they're telling me right up front in the headers there's an active change here. So Varnish will not even look at it. So that's just an important thing to know. So the Varnish cache, you can tell Varnish in bulk, hey, every page that goes through gets cached for 5 minutes. I really have no other criteria. All the granularity I was discussing, it may not be important to you. So you just tell Varnish in one shot, cache everything for 5 minutes, and it will do that. So, and you can do that in 3 different places. And I bring this up because eventually you're going to get involved in a situation where people are going to be like, I don't know, I'm sending through all the correct headers that the things should be getting invalidated in 5 minutes, but they're actually not. Or things that shouldn't be changing are changing. I want to know why. Okay, you can configure Varnish at the time when you build it, like you can do with other products. You can pass in flags with parameters. And then once you build it, those are specs that are built into Varnish. You also have a default Varnish settings that exist inside Varnish that will do things whether you tell it to or not. So the default Varnish cache setting is 2 minutes, 120 seconds. Even if you tell it nothing, if you keep all your configurations blank, Varnish will default to 120 seconds without you telling it anything. And then you have your VCL file, which is a special configuration, just like for, say, Apache or Nginx, where you can put in rules. And so you can put in rules in the VCL file that say, hey, cache all JPEGs for 5 minutes, no matter what. Cache all Word document files all day, no matter what. And put very fine-tuned instructions in there. And a good thing to know is that the people at Varnish, just like the people at Linux have created Red Hat, Varnish actually has pre-prepared VCL files if you want to. I think you have to buy them off them, and some of them are free, where you can get a configuration that's been done for a news website or a configuration that's been done for a legal website. You can get some of that in the community. So the VCL file for configuration, and so this will come up, and so this is why I have to bring this up. There are three different timeouts because this will happen. Someone will contact you will say, Varnish is saying to me that it's timing out. And that's a problem. But the problem is Varnish never times out. It can, but that's like 1 in 10,000 times less. When Varnish says I'm timing out, it is always telling you the web server has timed out on me. And so I return a timeout fault to the requester. But Varnish itself never times out. So, but here are all the ways where Varnish will time out, and they're all the fault of the web server. So, like for example, in the Varnish VCL, you're saying this is the back-end web server to connect to, this is the port to use, and then this first timeout is how long should Varnish wait when it tries to contact the origin web server until, and it has no success, and then it would return like a 503 error to the user. We're saying here, wait 600 seconds. Like that's an unreasonable amount of time. So but that's the max amount of time for Varnish to wait to try to connect to the origin web server, and if it fails, return an error. Then, once it's connected, you have another timeout where you say, how long should I wait to get the first byte of data after I've connected to the back end? And then lastly, say data is already streaming to Varnish. If there's an interruption between bytes, how long should I wait between bytes before I consider that a timeout? So when Varnish times out, you have all three of these areas to check where the timeout is really happening. Is it timing out trying to communicate to the web server, or is that always successful, but then the web server returns information so slowly that Varnish times out waiting for stuff? So those are two different kinds of errors, and it is almost always the issue that Varnish times out waiting for data from your web server. And the problem then is usually you have massive MySQL queries going on that are locking tables in MySQL unexpectedly, like you weren't sure, you don't even know that's happening. So those tables lock up. Now you have 100 users concurrently locking up that table repeatedly over and over and over again. And though it sounds unbelievable, in a couple of minutes, that kind of table locking problem can take down 20 web servers and your MySQL server and lock up Varnish in 2 minutes. And the website team will be like, what happened? And so this typically happens in scenarios where, we usually get 1,000 users a minute, but we put on this huge special, and now we're getting 10,000 users a minute. And you know that query we used to have that goes in there and finds every user who's online and organizes their name for everybody to see? Well, when 10,000 people do it at a time instead of 1,000, it takes down your MySQL server. So you've got to figure out, how do I make queries that are more judicious, let's say? So the point of that is, if Varnish gives you a timeout, it's almost always your web server and your processing is too slow. Varnish rarely times out because it broke. Okay, reasons why things will not get cached by Varnish. Information that's in the headers coming in either direction that will tell Varnish, I can't cache this page. If you are using HTTP basic authentication, Varnish will not look at your thing to be cached. If you set any kind of cookies, now this is also another confusing item because people think, hey, shouldn't all my pages get cached? Well, every time you send a cookie has a unique value. That unique value could be changing the content of the page, which it often does. So Varnish looks at the thing and it says, hey, cookies? Sorry, not caching it. So now, what happens is developers will come in and they'll go, look, man, I set everything up. Man, Varnish is supposed to be caching. But the website is like really slow. We don't understand. And I look in the headers and it says it's not getting cached. And that's because you set cookies on every single page. So as it turns out, when you get to the enterprise level, how you use cookies actually becomes an extremely delicate operation. And you cannot exist anymore in an environment where we just like cookie everything and we keep track of everything by cookies. If you do, it's going to blow a lot of your potential for caching. So you must start to think of cookies also in an extremely judicious fashion. Etags and last modified. Sometimes you want to be really specific about telling Varnish when you want to cache and uncache. So you use Etags or last modified. So in an Etag, you give a unique hash ID to this page. Varnish caches it, sends it down to the browser. The next time, and the browser sees that Etag. The next time the browser gets that same request from the user, instead of just going to go get the page, Varnish, the browser goes up to Varnish and it says, hey, did the content that's associated to this Etag change? And Varnish says, no, it hasn't. The browser doesn't even have to connect now, and it takes it out of its local cache. But if it goes to Varnish and Varnish says the Etag has changed, yes, Varnish sends the page new to the browser again. And that's where so Etag communicates down, and then once the browser knows that there was an Etag, it sends up the if num match to try that transaction that I just described to you. So you can do that with an Etag, or you can do that with a time-based date stamp, basically. So same thing. You send, you say this item was last modified at whatever time. The browser checks if it because it knows it got that tag. And if it hasn't changed, it knows it doesn't have to even bother to go get the full page again. So I know I'm moving through some things quick, and we're actually getting close to time. But the point of the entire exercise here is just to open your mind to all of this information if you haven't seen it before, and it helps. You'll know the next time you come here or you come upon this issue, you'll have some ideas about where to look. So here's a very interesting thing. For those of you who are using cookies and who are saying, hey, but wait a minute, I have to use some cookies and I got to have some caching. That's where this tag called vary comes in. Varnish will look at vary in both directions again, coming in and coming out. And it will, and if you put a command in your headers that says, hey, cache everything, but vary it on language or vary it on cookies. So then Varnish will actually cache your page based on the cookie. And then so it can cache cookied pages and have cached cookied pages. And as long as some user keeps coming back with that same cookie, it'll return that cached cookied page. Or if the user keeps coming back with that same language on that page request, it'll just send the cached language page back. So these commands of how to use vary are actually extremely essential if you want to have cached dynamic cookied pages and cached dynamic language pages. So vary is really important to know, and there's a very good article on how to hook that up. So I explained earlier, expires is really blunt. You just tell Varnish, look, on January 3rd, this page has to expire, and it does that. So now here's cache control. Cache control says every public proxy, every public surrogate from the origin on down has to listen to this cache control message. And I am telling you all that the maximum age from when this gets first put into the cache is 3,600 seconds or 5 minutes. And then it's, okay, so this is the command that all browsers must listen to. Interestingly, for every other proxy in the middle, the S-max age actually supersedes it. So if, on the other hand, the cache control headers are telling the proxies in the middle, like that network proxy that's in front of your entire school or in front of your entire legal office, this will actually keep it in the cache for 10 minutes or whatever that equals, even though this is saying cancel in 5. So this is something to check, and this is where your interference can be going on, that the proxies are being told you can cache this longer than the browser is being told. So you need to keep these in line, those cache control timings. And then, like I said, age is just telling you how long something has been in the cache. It's not putting something in the cache. And then basically, I was telling you about all the points in which caching commands can be going on. So they can be going on in Varnish's VCL file. They can be going on in the S-max age. They can be going on in, which is for proxies, in the max age, which is for browsers. And then there can be just the hammer, the blunt expires at such time. So this is Varnish Plus, Varnish Modules, and Varnish 5, which is out now, which no one is using yet, because it's like Drupal 8. It's a very big update. Many people are scared of it and don't want to know like all the new features and don't have time to get involved. But Varnish Plus is where you can turn, if you want to find pre-configured Varnish and other pre-configured resources, or rather than hosting your own Varnish server, you want to go to the Varnish people. Look, give me a server, configure it for me, put it in front of my website, you take care of it, we don't want to know anything about it. HTTP2 is not caching, but it's worth knowing about. Typically, every web page today, the average busy enterprise web page makes 100 requests, HTTP requests, to servers to get information, downloads 1.1 megabytes of information, and contacts 10 different domains to load a page. So that, and every single one of those requests takes some period of time, and that's called latency, right? The latency across the network. So HTTP2, which is out there now, and almost every modern product, whether it's a cache server or a web server or Node.js, can use HTTP2. What HTTP2 does instead, the browser opens one pipe off your computer, and then it feeds every request through this one pipe, and it can do them in levels, and it can do them broken up in big chunks and small chunks, like basically whatever works, that's fastest. And that's very similar to how network packets go across the network. So the browsers are saying, we're going to handle our HTTP requests the same way networks handle packets. And in theory, the theory is that this type of connectivity is many times faster than the 100 unique requests that HTTP1 has to do. So that's worth knowing about, and you may want to look at it at some point for your servers. So keeping in mind that there's proxy and browser caching, there's cookies and caching, now Drupal 8 caching. Okay, real quick, because this was the easy part, like I was telling you. You can cache stuff in your custom modules, in Drupal contrib modules, in Drupal core, in all your PHP functions like I discussed with you. Now you send stuff out in render arrays, you modify some settings in Drupal. Views has caching, panels has caching, and now you modify the headers, which goes to Varnish. Stick with me. Okay, so we went through that. Yep. No problem. Okay, so cache contexts. When you're making your render arrays, these are all of the items available to you in Drupal by which you can say, I need this cache, changed or altered or invalidated. It could be based on cookies, on IPs, on the request format, on the session, on the theme that's in use, anything in the query string, anything about the users or the nodes. All those things you can use as information to invalidate a block or a page. Okay, this is the last important part, and if we have no other time, this is the last thing we'll discuss. This is a typical render array. So say you build a block, and you return, the user's name, hello user, great that you're here. Here's 2 articles you might be interested in, and someone is trying to communicate to you, right? That's a very dynamic block, right? You need that to update every time a different user comes to user central page, let's say, right? So, and this block is the brains. So we're going to quick cover all the items that can be in a render array. A prefix is something that you want in front of the output of your main block. Markup is just ordinary HTML that you would like to spit out. And in it, you could be putting dynamic content like usernames. Suffix is stuff you want after your block. Theme is what is the theme that's going to style this block. And then you have pre-render function. You can say every time data comes into this block, before you build the block, I would like to do some things in this function with it first. So that, for example, if data in this block is coming from some API that sends you anywhere from 10 to 100 names, depending, right? And you're not sure how many are going to come. So you can write a function that says, hey, first, before the data goes into this render array to get handled, let me check how many items are in it. And if it's above 10, cut the others off and only always deliver 10 items. So that's what your pre-render function can do. If you haven't seen attached, this is how you attach jQuery or CSS or anything else actually to this page where this block is going to run. And when you include your jQuery or your JavaScript or whatever using attached on a block-by-block basis, what Drupal will do for you then is if this custom JavaScript only actually is needed for this block, Drupal is only going to include it on the pages where this block runs. And I don't know if you've had that experience in Drupal 7 where like all the JavaScript on the entire website loads on every page, right? So you got 550K of JavaScript on every page, 750K. If you get into the granular strategy, you could bring it down to more like 100K on every page, which when we know about HTTP requests, we know is a plus in your favor. So now comes the caching commands. So here's where you can say, based on the changing context, this block's output has to be invalidated, so this whole page is going to get invalidated, the headers will be changed, and it will get dumped out of the Varnish cache. So you can say, every time the user is different, it needs to get uncached. Every time there's something in the query string that has quantity, this page has to be uncached. So tags are, I have an association with node number 42 in English. If that node changes, this block has to be uncached. So Drupal is actually watching in the background for you all the time. If any node changes, it looks through its caching list and it goes, what blocks, what views, what anything has to be changed that said, if this node changes, I want to respond to that. So it can also be responding to a system performance update, which is actually clear the cache. Okay, so and then also you can put just bluntly, irregardless of all of this, no matter if these things, none of these things happen every 300 seconds, invalidate any page that this block appears on. So this is what these cache keys is the name of my render array. So if other render arrays want to respond to events where they could go, hey, if that block ever changes, invalidate me. So, and this is how you are known. This render array is known in the system by its keys. So now we have covered all of the most important aspects of, so now you know blocks can be cached, that you know. Okay, you know about working with Redis and Memcache and Cloudflare, and in Drupal 7 you have modules like Purge and I think there's Expire, and these are modules that help you expire things out of the Varnish cache if you need to do it manually or programmatically, and you need assistance with that. We are almost at the end. So let's see for a moment here. My down arrow has, there you go. Big pipe. Okay, so big pipe is Ajax, as I explained to you. So what Drupal will do with big pipe is when you turn it on and you don't have a Varnish server, Drupal will keep in all of its cache tables internally a big render array of your full page. And it's going to know all the blocks that are on that page, and it's going to deliver them independently after the full page has been sent to the user's browser. It will use Ajax to pull in all these blocks, and the page will be complete. That is essentially, that is not an exact technical description of big pipe, but it is an extremely accurate one. Right, you know, that's all I'm telling you is blocks get filled in later after the framework of the page has been sent down to the user. So I think I've reached the end of our time. I believe I don't have any other relevant information. There's a couple of slides towards the end for looking online for education. And what I always tell people, in case you didn't know, but every session that has ever been presented at a DrupalCon, anywhere ever, is actually available on the Drupal Association channel on YouTube. So anything you feel you've ever missed, a topic you're interested in, it's available to you. Thank you, and I can't believe we made it. So have a good afternoon and a good weekend, and thank you for coming in. Thank you very much. And I am very sorry to the HTTP debug